right, everyone, it's time for question 3, and we've got melons from two different distributors, and it looks like they are normally distributed with certain means and standard deviations. Okay, so for part A, this is the easy one. So for one melon, that's kind of key there, selected at random from distributor J, what's the probability that the melon will have a diameter greater than that? Okay, so the idea is we have our predicted melon weight, or we have our actual melon weight of it being 137 or greater, minus what we thought it would be, which is just the mean, divided by the standard deviation, which is 5. Now, one thing I want to draw from this is technically we are using this formula on the reference sheet right here. We have the standard deviation that they gave us divided by the root of n, but notice here the sample size for this was only 1. So that's why, if you divide by the root of 1, you're just dividing by 1. And anything divided by 1 is itself, so that's why that's not really changing there. But I just want to give a point to that. So we have a z-score, that's what we're calculating here, of, this is going to be 4 over 5, or 0.8. Now the question is, what is, I guess we'll say 0.8, what is the probability that our z value is greater than or equal to 0.8? Actually, no, just greater than, because they say greater than 137. This is really what we're finding, the odds that our z-score, that we get something bigger than that amount. And so we can go to the table. I'm going to use the z-table because, again, you might not have a calculator that can do this. And we'll find the z-value of 0.80, which is right here. Now, again, notice that that's equal to 1 minus the probability of z being less than or equal to 0.8. So it's the other way around, because the idea is I want the area greater than, I want this sliver above, but I can only find the amount below. So that's what I'm doing right now. The amount below to the left of 0.8 is shown on the table, which is 0.7881. And so we get a final answer of I believe it's going to be 2119. So that is the probability. Let me see if I need to give any extra wording there. Yeah, so I mean, technically I might want to say the probability that the weight is greater than 137, but this is analogous to saying that. Okay, check the scoring guideline later. I feel pretty confident on that. Part B, now they tell me about melon K, the probability that okay, so they tell me essentially the answer to the same problem when it's K's version. Okay, and for all the melons at the grocery store, 70% of the melons are distributor J and 30% are distributor K. All right, sounds like we're about to see a tree diagram. So for a melon selected at random, what's the probability? Yeah, tree diagram. Okay, so when you select a melon, the first thing that's technically going on here is we need to figure out whether it's distributor J or distributor K. And so you'll select one from distributor J 30% of the time, and from distributor, other way around, reading it out of order. So, I mean, I was just quickly looking up and I said, oh, J and 30 are next to each other, but make sure you're reading the sentences. 70% come from distributor J, 30% from distributor K. Okay, from there, we'll just fill out, all right, greater than 137, and I'll say less. Who knows how much of this I'll need, but why not show off? Maybe they can give you something. Okay, the odds for distributor J, that's what we did in the first half. We calculated that. It was 0.2991, or 2119. And again, the other version is what we had before, the 0.7881. And then they told us for distributor K, it is 0.8413, which means the other is 0.1587. Okay, so there's my tree diagram. So what's the probability that one melon selected at random will have a probability greater than 137? So I'm going to write it like this: probability of melon weight greater than 137. That's calculated like this: 0.7, the odds of selecting a melon from J, times the odds of that melon being greater, plus the odds of getting one from the other distributor, times the odds of getting a melon that weighs more. So again, the idea is, on your way to select a melon that weighs more than 137, you have to first encounter which distributor came first. So that's getting multiplied into the probability. Again, the idea is, when you say the word and, you multiply. When you say the word or, you add. So the idea is, did I get a melon that was greater and from J? That's why I'm multiplying. Greater and multiply. Or did I get a melon that was greater and from K? So that's kind of how that's calculating. So let's just write what that is. 0.7 times 0.2119 plus 0.3 times 0.8413. And I get 0.4007. Okay. Last but not least, part C. Ooh, it says given. Given that a melon has a diameter greater than 137, what's the probability that it was from distributor J? This is actually, to me, an easy question because let's write this out how it is. So it's J given, so say greater than 137. Now that is the probability of, it's always good to write this out, J and greater divided by the probability of greater. I should also put 137. But the idea is you want to write out the definition of this formula, which is up above, where is it? Conditional probability, right here. You want to write it out in context so that they're clear that you know what you're doing. To me, the given probability questions are easy once I memorize that formula, and it's easy to get credit by showing that you know what's going on. Okay, so distributor J and greater is just 0.7 times 0.2119. That's J and greater divided by the whole probability, which is 0.4007. So we just calculated 0.4007. And so let's work this out. 0.7 times 0.2119 divided by 0.4007. And I guess I'll write approximately because I'm about to round. 0.3702. And I guess I could put approximately here as well. Okay. And there we go. So let's see what happens here. Question number 3. Let's look at that scoring guideline. Okay, so checking the scoring guideline, we can see in part A that I actually showed a lot of the work there that they wanted, and I also calculated that all out correctly. Now, you don't necessarily need the 1 minus there. Let's just look at the part A. So, did we indicate that we're using normal or approximately normal, showing the correct components of a z-score? Did I show that I was trying to find the probability of being greater than 0.8, so they need to see that probability of z being greater than 0.8 or of x being greater than 137? Okay. Let's see here. Showing correct boundaries. Labeling the lower unit of normal CDF calculator statement. So again, you can just write a calculator statement there. And you can see student examples of work they've submitted of kind of how to write that. Or a conclusion using the word greater than. Again, reports the correct normal probability with the responses set up. Okay, part B. Let's just look at part B. Right, so again, you can see pretty much my exact tree diagram right there. Now, I didn't actually calculate the ends of the branches, so I should have done that in general, but I don't think I actually had to at the end of the day. You can see I did get the correct value, 0.4007. And I showed the explicit work to get those values. So they just kind of, what they did ahead of time was they multiplied all those values so they would have them ready to go, so they wouldn't have to go back and re-multiply them, and I did. And then we ended up getting the same answer here. I have some differences based on my numbers that I had for rounding. That should be okay. Actually, let me see here. Or did I just type something wrong? Or did I round wrong? No, I ran it correct. So again, based on what I had, that'd be okay for me. Okay. So let's just read the scoring breakdown explicitly. Part B, did I get the correct probability and work was shown using values from a tree diagram or some other appropriate method? So I think I definitely hit on that. Again, what you might want to do is actually calculate all of these ahead of time. Even though you might not use them all, show the 0.7 times 0.2119 and show what it equals, so on and so forth. And then for part C, let's see here, essentially correct if the probability is computed correctly and work is shown, how the probability was found. So again, show the formulas is what they want to see there, right? 1 minute, just reading something for myself. That's so weird. Why did they get 0.3701 when it clearly rounds up? Whatever. Okay.